The mock SAT last Tuesday, how did it go? How many of you did take it? Did take it. Alright, so, and I'm talking just the math part. Roughly what percentage of problems do you think you struggled on? 20. Are you being serious?
Like out of how many questions?
Yeah, but then he's serious.
Oh, I don't know. Like.
What, so percent, you could say how many out of 10?
Maybe 20.
20% for you? Okay. Like ballpark.
There's 20.
How about you guys? Okay. Let's just talk real quick about how this test works. So put your stuff down for a second and listen. Everybody takes the same tier 1 questions. I don't need to write like that. And they're kind of the basic ones. Then it splits you off to the higher tier for the second, I guess they call it module. And it doesn't tell you which one you're branched onto. Like it's not going to say you're in the higher one versus you're in the lower one. But you kind of know because of the level of questions that you're getting. Okay? It's like, do you know how NWEA scales each question based on how you did and have done in the test? It's like that, only it's instead of each question doing it, it's module 1 and then module 2 is scaled off of that. So the entire second module is either easier or harder based on how you did the first time. So with that knowledge, just curious if you're willing to share, if you feel like you got module 2 on the second one. Because when you start saying like, oh, I struggled on 25%.
Do you need any tissue glasses?
Sure. Awesome, thank you.
Yep.
When I struggled on 25%, it might be because you're in that upper tier, and so they're throwing problems that are harder at you. Do you feel like that could have been? Okay. Yeah. So you can still, if you feel like you're getting easy questions that second round, you can still get a good score on SAT. You just have to get more of those correct than the harder ones, right? Like they don't expect everybody to do all the harder ones correctly unless they're shooting for a perfect score. But if you feel like the whole thing is easy, just hopefully you're doing the answers correctly because then you'll need to get more. Do you guys know the cutoff score for graduation for SAT? Well, I meant just for math.
Like 205.
Okay, well, first of all, the SAT's 1600 is a perfect score. 800 for each subject. So, I think, so 200 is bad. Yeah.
480.
Yeah, 480. Now, somebody told me recently that it was different. Does anybody know? It was 480, and somebody told me, well, I looked it up, and it was 480. And then another guy told me, this is teachers, by the way. Well, I checked in the handbook, and it said 500 or some other number. So you're shooting, I'll look it up here in a second, but you're shooting for those numbers, right? Like, if you're down in the 3s or 4s, that's not good. So this week, and then Monday, of course we don't have school Friday, so this weekend, Monday, we'll be mostly doing this. Today we're going to talk about logarithms just a little bit, but mostly we'll be SAT reviewing and talking strategy and that kind of stuff. You guys understand, knowing the math obviously is awesome, but there is a big part of taking the SAT that is strategy, right? Maybe even half of the tests you could say is good test-taking strategies and good skills on just test-taking. So that will be something that we do talk about. How much time do you have for each one of these? Roughly.
35 minutes.
Oh, I meant, sorry, per question.
Like a minute.
Yeah, it's fast, right? And some of these you can get probably 45 seconds back on, and some of them, though, you might be stuck and have to take longer. In terms of Blue Book, like the interaction that you have on Blue Book, how is that going for you, based on the practice test? How about this? Give me a thumb, just so I can see everybody's opinion on that. Like, well, I don't mean like it, because that's sort of irrelevant. But like, how is it working? Like, do you feel like you're maybe missing points or missing questions because of Blue Book, or is that not an issue and you just don't like it? Like that's what it is. And did I answer your question?
I don't know.
Do you feel like you understand how to use it effectively?
Yeah.
Okay. It's so we're kind of in different places. Well, my first strategy would be write stuff down, because all year long, all your life, we do math on paper, and then you have to take these computer tests, and it's hard. Like, I would struggle doing a test on a computer, because I like writing it down in front of me. Okay? Now, does that mean you have to write every one of these down? Okay? If you want, sure. I would say no, but definitely any calculations, you need to be disciplined and force yourself to write them, because you will make mistakes otherwise. Another thing about these kind of tests is there's often a lot of reading. These 4 don't have a ton, but some of them do. And that's annoying, because it shouldn't be a reading test, or at least not a timed reading test, but we have to deal with that. In terms of, well, how many of you did use your scratch paper, what you would consider like a lot? Okay, good, so you have some good habits established. When some of you came in, I had this screen up, which is only showing you the formulas that they'll give you. Did anybody use those? Okay. It's rare to get a problem where these actually help, but they're there. So if you feel like they could be helpful, click them and look at them. Remember, it's just like a menu item. But we know that most of the problems that we do on this SAT are not going to be areas and volumes and stuff like that. So, but don't miss that they're there in case you do need it. What do you think was the biggest theme in terms of questions? Could you identify that you saw on the practice, I mean? What was it? Okay. Well, I mean, here's what I'm asking. Like, we break it down. There's, of course, the difference between geometry and algebra problems. But geometry isn't super common. Like, how many do you feel like you ran across for geometry? You said 2 of 7? Okay. Okay. 3. Okay. So somewhere in there. Let's say an average of 5, maybe. Okay, we will review some geometry, but the test is more algebra, for sure. And then in terms of after that, there's linear, like y equals mx plus b stuff, and then there's like number 4, which is quadratic, and actually number 5 too. So which of those do you feel like were harder for you? Geometry and then what? And algebra for you? Okay. I know geometry is your favorite subject. You did good. You fought your way through it. It was good.
My favorite
one of the hardest things about taking tests like this is that variety being shoved at you. So just a big skill that you're going to need to remember is identifying what you're dealing with. New problem after new problem after new problem. So let's use that as we get into this. 2 sides of a triangle. As soon as you read that, what should you probably do? I would say draw a little picture on your scratch paper. So we have 4 and 6. Perimeter of the triangle is 18. What does perimeter mean? Yep, distance around. So maybe write P equals 18 now. It says, what is the length in centimeters of the third side? Seriously? This is a SAT problem? What is it?
4 and 6.
Okay. Yeah, and like, hopefully not this one, but if there's ever any doubt, you get a calculator on every problem. Use it. Yes, you do. You can either pull it up or have your own. Now, I'm going to suggest bringing your own because you're familiar with it, but we'll talk more about this. I honestly feel like Desmos is a better grapher than your calculators are. Okay? Because you can just grab it and move it around, and it's so easy to see. We'll talk more about that. Which value of x is g of x 25? What do we do?
25 is equal to x squared.
Yeah. If you're doing pure algebra, that's your solution or your equation that you're about to solve. Okay? So what are you going to do next? Yep, subtract 9 and square root. Okay.
Oh my gosh, did you get that?
Next one. Which equation has the same solution as the one given? Some of this is just getting used to their wording. Like they could just say, what is x? But they don't. They want to make it more confusing. So what did you do to solve? All right, good. And then?
Yeah, you don't have
Oh. Oh, geez. Number 5. What do?
to break it up.
The X out.
Yeah, what do we call that? GCF. Yeah. So, do you need to write this one?
No.
Probably not. You could just check which one of these, if you distribute again, which one is equivalent, which is A. Okay. Which module do you think that came from?
What?
Yeah, that was module 1 stuff. Okay.
Wow.
Yeah. Is that kind of what you ran into when you were on this practice test?
They weren't that easy.
See, that's annoying. They weren't.
No.
No.
Because I did hear some people talking about some easy problems, but maybe not that easy. Okay. Well, those were kind of dumb. But these are part of the official newly released practice tests. So you could run into some like this. Alright, with that. We'll look at this later, but
Oh,
take a look at this one.
oh, I remember this one.
Yeah.
I had one of these problems on
You did have one
Yeah.
like this?
I did too. I definitely got it.
I had one. I forgot how to do it.
We're not going to take time to do all this right now, but just
This was the
see what you remember about it.
I know.
Okay, a couple of reminders. Remember, an arrow on a line is the notation for parallel. Yeah, good job. I'm going to move those, but yeah. Okay, what else about parallel lines do you remember?
Yeah, those things equal one unit.
Which, like here and here?
Yeah.
Good, thank you. You could just set them on that table. Awesome, thank you.
Yep.
These two are called a linear pair. Do you remember that? And so they do add up to 180. And what about here to here? Those are congruent. Those are vertical angles. Okay. Parallel line angles. So I could take this 123. Where else could it go?
So the outside.
Like here?
No.
There. No.
Yeah.
Those are corresponding angles. Okay, where else?
You could do that with the 16.
Uh-huh. Where? Like here?
No. Yes.
Okay. But where else can this one go? Here? Like this whole thing?
Yeah.
Because those are alternate interior angles. Okay, good. 123 could go here, alternate exterior or vertical. So remember, these are a lot of copy paste, right? These kind of things. What? Okay. In terms of the 81, do you guys remember? Just going to clear all this off. Do you remember an isosceles triangle? This notation means what?
The sides are.
They're the same. And if you have that, remember their opposite angles are also congruent. Okay? And is it safe to do this? In other words, are these congruent?
Now they are.
Well, yeah, so one of the biggest tips I can give you on geometry problems is it's easy to make assumptions when you have a picture. And so what, is that okay to do? No. Things that look to be congruent may not be. We have to prove it mathematically. So we'll come back to this one. This is one of the harder kinds of problems that you'll get. In fact, I have a slide of 10 different ones of those. So we'll work through those. But we'll kind of get into that more tomorrow. Ready to switch gears a little bit?
No.
Grab your note packet, please.
No, you get it.
That's true.
Also, you got my homework is missing when I literally showed it. Because I said I forgot to turn it in, and you were like, well,
Yeah, he just
show
doesn't
me
care.
right now, I
And
don't
then
have
you
it.
did, and then I forgot.
Yeah.
God just wants you to fail.
Also, I have my review.
Tuesday. Next Tuesday.
Yes, sir, I will.
15th.
Yes, sir, I will.
At
Do you
8.
get in trouble if your students fail?
What is that? Is that the
Okay,
review?
that's me.
Hang on to it, please.
Okay. Do you get in trouble?
No,
your
if I
students
have
fail?
too many failing, yeah. But
Like, if we all failed your class, would you?
yeah, that would be an issue. More for you than me, but yeah. All right.
More for you.
Okay, so the quiz that we just finished on Friday was kind of a good breaking point between exponential and logarithmic work. And then we'll swing back and do both at the end of this unit, which will not be for another couple of weeks. But here's the switch now is, well, before we do that, what does this look like on a graph? So try to think about what you remember from last week and the week before. Just draw it in the air. I'll just watch your finger. Yeah, so it's that, right? And where does it cross the y-axis? Like what is 2 to the 0? It's 1. Okay. All right. And then of course we know that we could make that reverse and decay by doing what to the base? Like what would you change about this equation when you make it an equation? What would you change about that to make it drop instead of grow?
Less than 1.
Yeah. So 2 could be what? 0.5. Yeah, make that a half and then it's decaying. If we did 1/2 to the x, that's looking like this. And that represents a lot of things going on in life as well. Okay, so based on what the base was, this was growing or decaying, and it could happen fast or it could happen slower. We talked about things like what is the rate? If I give you like 1.2, what is the rate of, well, I about said growth, but you know it's growth. So what's the rate of growth for this? You know, we can make this an equation if you want, but what's the growth rate? Rate.
Oh. The 1 plus.
1 plus r equals 1.2. Subtract 1 and you get 0.2, which is what? 20%. 20, okay. What if it was this one instead? 0.63 to the c. And of course we need an a value. Okay, it's decay. So what's the decay rate? 1 minus r. And then do what? Subtract 1. 0.37, but negative. And what percentage is that? 37%. Okay. Alright, so we did some of that. We did writing of equations, like population. There was the rabbits problem, right? Oh, by the way, I didn't get to tell everybody this, but I am throwing off number 8. So if you struggled on that one, that was the ants problem. If you struggled on it, it's because I forgot to take it off. So it's not going to count against you at all. Sorry about that. Anyway, but you had to write an equation and use it to solve. And then we did interest. Anybody remember the interest formulas? Let's do those two. Let's do compounding monthly. Which formula or equation do you use for that? P, good. 1 plus.
Over N.
Awesome, yeah. And N was what? Yeah, number of times it compounds in the interest period. So usually the interest is annually. So quarterly, what would N be? 4, monthly is 12, etc. Okay, what was the other one? And why did we suddenly substitute an E in there? Continuous compounding. And so we had to be told that. That wasn't something you just figured out, right? You had to be told this is compounding continuously. All right, well, all of that was focused on the base and plugging in a variable for t, plugging in a number for that variable t. But we ran into trouble and got stuck if we had to do something like this. If I wanted to know when will I have $5,000 if I deposit $2,000 compounded continuously at 4%. Right? We were stuck.
Yeah.
Like we had to do our calculator and just play with numbers until we got in the ballpark. And so that's very inefficient. Where we're about to go is how do we get that t out of the exponent? That's what the goal, or one of the goals of this section is. How do we solve for an exponent, a variable exponent? Everybody clear on why we're doing this? Okay. And that's called the log or logarithm. And here's a good illustration of when you might use it. You guys know the scale for earthquakes?
Yeah.
Like people talk about them, I mean, we don't necessarily know it, but it's called the what? Anybody remember? Seismic is what it's measuring, but we usually use the Richter scale. But yeah, it's measuring seismic activity. Okay. So this is a good example of when you might need that. So seismic waves that are traveling through the surface of the earth. So y equals 10x is kind of the basis for that scale, and it relates the height in microns. How big is that? How big is a micron? Okay. It's it's short for micrometer. You just kind of give it a nickname. You guys know your metric prefixes? Micro is 1 millionth. So take a meter stick and divide it by 1,000,000. It's tiny, right? So is the earth moving very much in some of these little ones? No. Okay. So it's measuring the height of the wave in microns, and then the power, or the magnitude is the word that we like to use, that it can cause in terms of ground shaking. So, you guys know what a good, I shouldn't say probably good, what a strong earthquake number is. Have you been exposed to that enough? Like 7, 8, those are very destructive. Yeah. Okay. So, how big is 100 microns? Remember, amplitude was in microns? It's like a centimeter.
Yeah.
Okay? So if the earth moves this much, that's a magnitude of a 2. Which makes sense, right? Like that's hardly any movement. If it moves 10,000 microns, how big is that? That's like if you shifted the earth this much, that would be kind of significant, right? Right? Yeah. Okay. So that's a magnitude 4. Well, how are we going to figure out what's in between? Like, what if it moves a measurable amount that's in between the powers of 10, like 10 to the third and 10 to the fourth? What do you predict is in there? What would you predict for a magnitude of a earthquake that moves the earth 5,500 microns?
At least at 3.5.
Okay. Like we want to think that it's right in between 3 and 4, right? Okay. So basically, here's what we're solving for. Remember, magnitude, I'll write it this way, is 10 to the x. So if we have 5,500, sorry, that was amplitude, not magnitude. I'm going to use an A instead. If we have 5,500, how do we get that x out of the exponent to solve for x? That's what we're trying to deal with, okay? Do you see how we have no tools right now to do that? Your brain wants to say, let's root this. What root are you going to take? If it was 10 squared, you could square root, but then we don't know what x is, so we can't root it. So we think that roughly 3.5 would work. Why don't you try it on your calculator? 10 to the 3.5-ish. So the amplitude is the distance that it's moving, right? A lot of earthquakes are up and down, like they shove up, but that's the amplitude. And then the magnitude is what we're calling like the power or the force of it, you could maybe think of. Its destructiveness. Does that kind of help? Does that help?
The amplitude's this way, right?
Well, it depends on which direction the wave is. It could be this way or this way. Most earthquakes are from plates shifting up and down to each other. So then it would be an up and down movement. Does that help?
Yes, thank you.
Okay, so what's 10 to the 3.5? What'd you get? Alright, I'm not just asking you guys, like everybody in here has a calculator. 10 to the 3.5. So we're low, right? So what do we need to do to get closer to 5,500? 3.7, I heard that. Okay.
How about
Now we're too big.
7.5.
Okay. That's pretty close. Okay, and again, we're running into that same thing. Like, this is a pain of having to cycle through a bunch of calculations. So, roughly 3.75. Well, here's the problem. Do you guys agree that 10 to the x is exponential? Right? So what shape will this 10 to the x have? Yeah, it's going to do this, right? Well, is that a linear graph? No, and so here's what we tend to do in our brain. If I see 3 and 4, I think, well, if this is halfway, this should be about halfway. But it's not linear. And so that's why we need a new function. Okay? All right. I'm going to zoom this back out. And I think, don't use your calculator for this. I think you can do it without it. What value of x makes this first one true? What value of x makes this one true? It is still a whole number. So 2 to the what power? 3, right? 2 times 2 times 2? How did you do that? So didn't you ask this question? How many times does 2 have to be multiplied by itself to get 10? Or to get 8? Right? You just did a log in your head. You just did that. Okay, here's what I mean. We're going to use LOG for the short version of logarithm, so you don't have to write it down every time. Okay, so we're going to write the logarithmic form, and you're going to see some connections to this. Tell me what you notice. That's the logarithmic form of the equation that you see. You said bottom. What is the 8 called? Let's start with the B. Base. So there's a base of 8. Okay, where did the Y? What is the Y? What would you call the Y? It was the value we're looking for, right? Okay, what is the X? Okay, so let's see if you can do this one.
Changes the way.
Log base 2 of 8 equals. Take note of the form. It's this example written with numbers. So what do I need to put right here? How many times does it take to multiply 2 by itself to get 8? Do you see the connection? 3. Okay? So this is asking for the power of the base that gives this answer, which has a weird name. It's called the argument. Okay? Try another one. Log base 10 of 100. What power of 10 gives 100? 2. That's what we're talking about.